All right, here's the next video. We're on page 10 of our notes here. So we're looking at complex numbers and powers of I. Okay, so complex numbers is kind of a new topic to Algebra 2. It's a huge topic in mathematics. So let's look at a couple of things of what happens here. All right, so here's the need for complex numbers, and we'll talk about what they are in a second. So if you took the square root of 9, you get 3. That's fine, okay? Square root of 4, you get 2. Square root of 0, you still get 0, okay? So all these are fine. These are perfect squares. Even if you took the square root of 2, you get some decimal, okay? But all positive and real numbers there. All right, so whenever you were to look at the square root of a negative number, this pops up. It says non-real calculation. For example, the software is in a real setting, and then blah, 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 a bunch of stuff there. Okay, so here is the need for complex numbers. All right, we'll start with the definition here. So the complex, or the imaginary unit, okay, is a unique number defined as I equals the square root of -1. All right, so saw in our calculation here that the square root of -1 didn't result in anything that we could come up with a real number. All right, so we have to put this definition of I that is the square root of -1. Okay, so anytime we have I here, we can use the square root of -1 in whenever we have the square root of -1, we can use I in place of that. Okay, that just lets us work with square roots of -1, any square root of a negative number. All right, so here's a corollary of that, which is just a fact based on something that's already defined. If you were to square both sides of this, you could take I squared, and if you square the square root, those are going to cancel, so that is just -1. All right, so here is a kind of an alternate supplemental definition of I as well. So if you square I, you get -1 here. All right, so that's the imaginary unit. A complex number is a number in the form A plus B I, where A and B are elements of real numbers. Okay, so A and B are real numbers like 4 and 6 and pi and square root of 2 and -6 and any number you can basically think of. All right, so A and B are just real numbers, and I is what this definition is here. All right, so examples of complex numbers would be, I don't know, 1 plus 2i, okay, where 1 and 2 are real numbers, and I is just I. You could have 4 minus 3i. You can have 6 over 5 minus pi I. All right, so these are all just examples of complex numbers. It is the form something plus a real part plus a complex part. All right, so we'll see this again and again with the A plus BI definition here. All right, so the deal with I is it is a defined term. Sorry, it is a defined term. I is the square root of -1. However, we treat it as a variable. So we treat I as a variable, even though it is a defined number. All right, so if I were to say, here's an example of 2 minus 3i minus quantity 4 minus 6i, I'm going to say 2 minus 3i, and I'm going to distribute my negative, just like normal polynomial operations. Minus 4, negative times a negative is plus 6i. Okay, so now if we combine like terms, we are going to get our answer here. So the 2 and the 4, or -4, are the real parts. So we're going to combine this guy, and we're going to combine that guy. All right, so 2 minus 4 is -2. And then we're going to combine the second guy and the I parts together. So -3 plus 6i is minus 3i. And that is the answer. All right, so we took these two numbers, which are both complex in form, A plus BI, and subtracted A plus BI. and then we got a single complex number back. Okay, so they work just the same. Okay, well, I'd prefer to go on the next page, but however, we're gonna smash right through this. All right, let's get rid of this example here. I want to make up some other ones. All right, so we worked with adding and subtracting complex numbers. Let's work on simplifying them, because we're going to need to do that. All right, so if I took the square root of negative 16, all right, so again, if I wrote square root of negative 16 in my calculator, I get a non-real solution. All right, so we have to make this in a form that works. All right, so whenever you see the square root of negative, you got to think I. We're going to get something with I in it. All right, so if I break this apart here, I can call this the square root of negative 1 times the square root of 16. All right, we can do that. Well, the square root of negative 1 is I, and the square root of 16, of course, is 4. Okay, so you just are left with I times 4. And the way I would write that to be thorough is 4I. So basically, if you want to go shortcut way, from here straight to here, the negative pulls out to be I, and the square root, you just take the square root of the number there, and you get just whatever that square is. All right, let's do another example where it may not be as nearly as friendly. Okay, let's do, so there's example 1. Here's example 2. All right. Okay, so this example, we're going to say this. We're going to simplify the square root of negative 80. All right. Okay, if you want to go straight there, that's cool. I could go straight there and say that you have I times the square root of 80. Okay, pull out the negative, there's your I, and then you get the square root of 80. But we want to go all the way with this. Okay, depending on what questions in ALEKS it has, you need to simplify all the way. So the square root of 80, we need to break that up into factors that has a perfect square. So our perfect squares are 1, well, 1's not going to be useful. We got 4, 9, 16, 25, 36, 49, 64, etc. Okay, probably not going to get much bigger than 36 or 25. Okay, so let's see, what perfect square goes into 80? 4 goes into 80. Yeah, that'll work, but let's see if we can do a little better than that. 9 goes into 80 now. Does 16 go into 80? Let's find out there. Let's just do a quick calculate here. 80 divided by 16 is 5. Okay, so I think that's going to work. So what 80 is going to do is break up into the square root of 16 times the square root of 5. Okay, and then we still have I chilling out over here. Okay, so I is I. Square root of 16 is 4. Square root of 5, well, we can't do anything else with that. That is reduced all the way. All right, so I would say for my final answer here, I would go 4I square root of 5. Okay, so this part of it, the I part is new. All the square root stuff is definitely an Algebra 1/geometry skill. All right, so if you need to brush up on that, that's fine. But pulling out the negative to be I, that's the important part of that. Okay, I think we still got some time. Let's go on the other side here. We are going to go on page 11. Okay, so multiplying complex numbers. Remember, they treat I just like the just like a variable. All right, so if you got two binomials multiply together, so 2 plus 3i times 8 minus 7i, we're going to multiply two complex numbers, begin by foiling them together, and then simplify. So FOIL, we can start with the first term, multiply that by 8. So 2 times 8 is 16. Okay, multiply 2 times negative 7i. There's the outside part. So that's going to be negative 14i. Okay, multiply the inside terms. That's 3i times 8, so that's plus 24i. Okay, and then the last term here is multiplying 3i times negative 7i. Well, that's going to be negative 21i squared. You still got two i's multiplying by each other. All right, let's see if we combine like terms and simplify this thing down all the way. All right, so 16, 16, that's fine. Then we need to combine 14i and 24i. Well, that's going to be plus 10i. And then we got minus 21i squared on the end. All right, so if you remember from our previous page, when we defined I, we want, or defined a complex number, we want our form to be a plus bi. That's the form we need. This is definitely not an a plus bi. Okay, the problem is we got this I squared business here. So this is fine, but the I squared stuff is wrong. All right, well, it's not wrong, but we need it to go away. So our definition of I is the square root of negative 1. If you square both sides like we did on the front, I squared is negative 1. So now I can substitute that I squared for negative 1. So if I do that, I get 16 plus 10i minus 21 times, instead of I squared, it's going to go to negative 1 here. Okay, so if we finish that out, we got 16 plus 10i. Negative 21 times negative 1 is plus, 30, or 21, I'm sorry, getting ahead of myself. All right, so we turned that into a real number there. We went from a complex number to a real number. All right, and then we got 16 plus 21 is 37, and then plus 10i. Now, that matches the form a plus bi there. Okay, I think that should be good on that. I think I wanted to look at something on page 12 as well. All right, so we're about to finish up these complex numbers, and then we'll look at the next topic here. Okay, these are cool. Powers of I. So we can cycle through powers of I. All right, we already saw an example. So I to the 1 is just I. I to the first power is just I there. We said I squared would be the same as negative 1. Okay. So the reason was, well, that's definition. So I is just I. So we took I as the square root of negative 1. So if you can't read that, let's see. And then we squared both sides, so I squared is negative 1. All right, we know that. Now we want to do I cubed. So we need to multiply I times I squared. So that's 1 power, and then there's 2 powers there, and they add up to be a 3rd power. Well, we know that I is just I, and I squared is negative 1. So the answer is negative I. Negative I. Okay, so let's look at I to the 4th power now. That's going to be I squared times I squared. Well, I squared is negative 1, and another I squared is negative 1. And when you multiply negative times a negative, you get a positive 1. Okay, those are the 4. Those are the big 4 that we're going to deal with. Okay, and we'll see here in a second. If I go I to the 5th, well, that's I to the 4th times I. Well, we're just going to get I again. And if we go backwards here, I to the 0 is going to be 1. Anything to the 0 power is 1. So here's the cycle. Actually, let's start with 0. Here's the cycle. So your cycle is 1, I, negative 1, negative I. 1, I. So I to the 6th would be negative 1, I to the 7th, negative I, and then rinse, repeat over and over and over and over again. All right. So this note here says, because the powers of I cycle through 1, so here's your 1, I, negative 1, and negative I, this repeating pattern of the 4 terms can simplify to the I to the n. Okay, so how are we going to simplify this? You don't want to count, cycle those around over and over and over up to get up to your number, because if your number is really big, you're not going to be able to do it. The light looks better. All right, so what you're going to do is, because the powers of I cycle through 1, I, negative 1, and I, These types of problems can always be simplified by noting what the remainder of the problem is. Okay, so I to the n is the same thing as I to the remainder. So we want to divide that number by 4. Okay, so if we have our example of I to the 25 here, we're going to take 25 divided by 4. Okay, I know we use long division here, but it's not really necessary. Does 4 go into 2? No. Does 4 go into 25? Yes. 4, 8, 12, 16, 20, 24. All right, so it goes in 6 times. Multiply 4 times 6 is 24. Subtract, draw the line, you get a 1. So this is our remainder. So that you get a remainder 1. So what this says is that I to the 25 is literally the same thing as I to the first power. Just whatever the remainder is there. Well, what's I to the first power? Well, it's just I. That's the answer. Okay, so that's just cycling those things down. Let's pick another one. Let's do another one. I'll make one up. Literally going to make this up. Let's do I to the 637. Okay. Now, if you had to count by 4s on that, that would take you a long time. So we're not going to do that. Let's take 637. Divide that by 4. All right, 4 goes into 6 once. That's 4. Draw the line, change the sign. There's 2. Let's bring down a 3. 4 goes into 23 5 times. Multiply. Subtract. There's a 3. 37. How many times 4 go into 37? 9. 9 times. Multiply, that's 36. And that's where. So, okay, well that worked out. Here's your remainder of 1. So literally I to the 637 equals I to the first power. Okay, because your remainder just matches whatever's there. And the answer is I again. All right. Say, for example, you got a remainder of, let's see, we could do this. I to the 638. Okay. And we know this. We can divide this out. So it's going to be remainder 2. Okay. You would say that I to the 638 equals I squared. So I to the 638 is -1. Okay, so hopefully, and if you know that since we're dividing by 4, we're never going to get a remainder you're only going to have a remainder of 0, 1, 2, or 3. You're never going to have a remainder of 4 because that means you didn't divide correctly. Okay, so hopefully that clears up what I is and the powers of I. We'll look at how to apply this in the next video.